All right, guys. 1.7 part 2. We're talking about solving non-linear inequalities. What you guys did on your test were all linear. Everything x was all to the first power. So now we're going to do non-linear where x is going to be to the second power. The way that we do that, we are going to factor. All right, the first thing you do is move all of the terms to one side. We've done this before. You're going to get everything to one side. Then you're going to factor. And then we're going to find intervals. We have to find places where the solution set is and where it isn't. We have to figure out where we're going to color. We have to figure out what makes the inequation true. So the way that we do that is by, some people have a table or a diagram that they use. I'll show you how I show you to do it. But what you have to remember is everything needs to be on one side. I would move everything to the left. You're going to factor like we have been doing a million times. And then we have to test a bunch of points. So let's look at some examples here. First thing I want you to, well, we'll talk about that in a minute. This is a quadratic inequality. It's quadratic because it's x squared, yes? So the first thing we need to do, what did the directions say to do? Get everything to one side. Move it to the left. Get your letters on the left. So if I move 5x over, this becomes minus 5x. And I move 6 over and plus 6. So minus 5x and plus 6, right? So I have x squared minus 5x plus 6 is less than or equal to 0. Everybody with me? Now, just treat this now like it's an equal sign, however you want to. We're just going to factor this because we have to find our test points, our boundary lines. What are the factors of positive 6 that'll multiply to give me 6 but add to give me a negative 5? Negative 3 and negative 2, right? Okay. So then I get the values x equals 3 and x equals what? 2. All right, that is not your answer. You'll have two parts to your answer for solving nonlinears. Your two parts of your answer will be 1, your number line graph, and 2, your interval notation. So what we're going to do, this is how it's a little different from what we did before. On my number line, I have to have 0, correct? And then I have to have my 2 intervals, my 2 test points. So I have 2 and I have 3. Go back to the very beginning, or go back to this step right here. What kind of a sign do I have? What does that say? Less than or equal to. So what kind of dots am I going to have at 2 and 3? Both of them are closed. And now we're going to figure out, are we going to color in between or are we going to color on the outsides? Well, now you got to figure out how to do that, right? Does everybody see how these are kind of like our boundary lines here? I have 3 sections. I have a section over here, I have a section here, and I have a section here. Let's pick a number that's in region 1. What's the easiest number to pick in region 1? 0. Okay, let's go back to the beginning here. Let's check 0. Let's see if 0 works. Put it into your original. 0 squared less than or equal to 5 times 0 minus 6. Well, what's 0 squared? 0. Is that less than or equal to, what's 5 times 0? Minus 6. You're fine. Is 0 less than or equal to negative 6? No. Okay, so this section does not work. Let's pick something in region 3. We always want to try whole numbers, guys, but sometimes you can't. Let's pick something in region 3. Okay, the number 4. Let's try 4. 4 squared less than or equal to 5 times 4 minus 6. 16 less than or equal to 20 minus 6. 16 less than or equal to 14. Is that true? No. So where am I going to color? In the middle. Should I test a point in the middle just to make sure? Sure. Yes. What's another thing we could test, though, if we don't really want to use decimals or fractions? Why can I use 2? Because it's included, right? You're saying that if 2 works, it's included in our solution. So let's just try it. 2 squared less than or equal to 5 times 2 minus 6, right? What's 2 squared? Is 4 less than or equal to 10 minus 6? Is 4 less than or equal to 4? Yeah. So did we color in the right spot?
Yep.
Good. Now you're going to write your interval notation based upon where you colored. What's my interval notation? 2, comma, what? And what goes on both sides? Perfect. So your answer is here. Your actual inequality statement, like x is less than 2, but they're greater than or equal to 2, but less than 3, something like that. That's not part of your answer here. I need to see your number line and your shading and your interval notation. So it's just one little extra step. You got to just make sure that you're shading in the right spot. You have to make sure that the points that you're saying, here's where it works, that you plug it in and it actually works. So let's look at this next one. 2x squared, this is the next one, right? Minus x greater than 1. Well, what do I have to do first? Move the 1 over. So 2x squared minus x minus 1 greater than 0. Agreed? Okay. So what's my, now I have to figure out what the points are that I'm going to put on the number line. How do I figure that out? We factor it. What are the factors? A times C, factors of -2 that multiply to give us -2, but add to give us a 1. -2, positive 1, good. My A term is not 1, so what do? Divide both my factors by 2. So I get x minus 1 and 2x plus 1. I still don't have my actual points on my graph yet, but I can figure those out right now. When I solve these two parentheses, here I get x equals 1, and here I get x equals -1/2, right? Everybody agree? Okay, so on my number line, I have to have those numbers. I have to have -1/2, and I have to have positive 1, and what goes in the middle of that? 0. Okay, we always have to have 0 on there. Now, I can go back to my inequality, and I can say, okay, what kind of a sign do I have at both -1/2 and at positive 1? Open or close? I have open. And now I got to figure out where I need to color. All right, I'm going to break. I have my sections. Right, this is section 1, this is 2, and this is 3. I would always start with 0. It's the easiest one to do. So if I plug in 0, all right, let's check right here with 0. I have 2 times 0 squared minus 0. Is that greater than 1? What's 2 times 0 squared? 0 minus 0. Is 0 bigger than 1? So does this section work? No. So where do you think we're going to color? On the outsides. We're going to color this way, and we're going to color this way.
So if it doesn't work in the middle, we automatically assume it's on.
I'll show you in 1 second. Now, should we choose? Should we check other numbers? Yes? Okay, what's a number over here in region 1 that I can try? -2. Okay, you want to do -2. So I say 2 times -2 squared minus -2. Is that greater than 1? Well, what's -2 squared? 4 times 2 is 8. So this is 8. Minus the negative means what? So 8 plus 2. Is that bigger than 1? Yep. Okay, so you're right. What's a number in region 3 I can try? Okay, try positive 2. So if we have positive 2, we still have 2 squared is 4 times 2 is 8, right? Well, what's 8 minus 2? 6. Is that still bigger than 1? So we're right. So instead of shading in the middle, we shaded on the outsides. Now, every once in a while, you'll get one that's all real numbers. They all work. And we'll talk about that later. But for right now, we're going to focus on either middle or the outside. Yes, ma'am. All right, now interval notation-wise, guys, how would I write this? This is negative infinity over here. This is positive infinity over here. We're going to use a union. Where that gap is, where my x is, you're going to use the union. So I start on the left-hand side. It's negative infinity to what number? -1/2. And then there's a gap. I don't use -1/2. It's an open dot. There's my gap. Where I write my gap, I just put a U. And then what's the next portion? 1 to infinity. Very good. So notice, in the first example, we shaded in the middle. In the second example, we shaded on the outside. Would you guys like to know a little hint? Okay, let's read the first inequality. Read the first inequality to me. What does it say? X squared is what? God bless you. Less than or equal to. What does the second inequality say? Greater. Less than, you shade in the middle. Greater, you shade on the outside. So this is how I always say it. Less than means in the middle. Greater means outsides. Let's do some of these together, okay? Before we even start, just kind of evaluate. Actually, we don't have to do that. Let's just look at this for a second. This is a nonlinear because it's squared, right? So the first thing you need to do is move everything to one side. So when I move the 9 over, this becomes what? X squared minus 9 is greater than or equal to 0. Once you have everything moved over, we can now look at our little trick. That says greater, correct? This says greater. So draw yourself a little picture. My graph should go like this. And what kind of dots should I have? They should both be closed. Why are they both closed? Because it's greater than or equal to. That little bit of information, guys, will help you. I promise you. Because now we factor this like it's a normal factoring problem. What times what is going to give me x squared minus 9? X minus 3 and x plus 3. Good. So my 2x values that I'm going to use are x equals 3 and x equals negative 3, right? So if we go to graph this, you guys just told me it's going to be negative 3 and positive 3. What else needs to go on my?
0.
Gotta have 0. Good. What kind of dots did you already show yourself that you're going to have at both of those points? Closed. And which way did you already say that you're going to color? Outside. All right. So what's an easy way we can check this? Plug in what? What would be the easiest to plug in? No, what would be the easiest to plug in? 0. If I plug in 0, should it work? No. So let's plug in 0. What is 0 squared? Is that greater than or equal to 9? Then you guys are good to go. If you want to feel a little better and check other numbers, fine. Pick negative 4. That's colored in, right? What's negative 4 squared? 16. Is that greater than or equal to 9? Yep. Pick positive 4. What is that? 16. Is that greater than or equal to 9? So we're good to go. Now our interval notation from left to right. From negative infinity to positive infinity is how we read. So what's my interval notation? Negative infinity to negative 3, bracket, union to infinity. Do you see how I wrote my interval notation directly underneath my graph? It literally shows you exactly where the starting and stopping points are, where your union should be, that sort of a thing. Just kind of a good thing to get into the habit of doing. We'll go through these examples and we'll be done. All right, we got to move everything to one side, on the left-hand side. Are we already there? Okay, so let's give ourselves some little hint here. Read the inequality out loud. It says x squared minus 2x is less than. Less than. Where am I going to color if it's less than? In the middle. What kind of circles or dots do I have? Both of them are closed. Okay, so now let's factor. What can I take out of x squared minus 2x? X. And I'm left with x minus 2 equals 0. Yep. So now set each piece equal to 0. I have x equals 0 and I have x equals 2. Agreed? All right. So you got your two numbers to put on here. I got 0 and I got 2. Remind me again what kind of dots I have? Closed. And if it's less than, where should I color? In the middle. All right, let's just check just to make sure. What could I plug in?
1.
Plug in positive 1. What is 1 squared? Minus 2 times 1. Okay, so 1 minus 2 is -1. Is -1 less than or equal to 0? Yes, it is. You're good to go. So what's your interval notation? Bracket 0, comma 2, bracket. Perfect. Let's scoop. Whoops. Where's 3? There it is. All right, is everything already set on one side?
Yes.
Okay. Read the inequality. What does it say? Is what? Greater. What does or mean? Outsides. What kind of dots do I have? Why are they both open? Good job. Good. So let's find our spots. What are the factors of positive 6 that multiply to give me 6 but add to give me 5? Ooh, 2 and 3. X plus 2. You're all right. And x plus 3. You caught yourself. So I have x equals -2 and x equals -3, right? Okay, so let's draw a number line. I have -3, I have -2, and I have 0. What kind of dots do I have? Open at both of those. Or tells me to color which direction? The opposite direction. Yes, ma'am. All right, so what's an easy number to plug in? Okay, we can do -4. Let's plug in -4. Should -4 work when we plug in to check? Yes. So I have -4 squared plus 5 times -4. You guys can do this in your head if you want to. You don't have to write it down, but I'm just showing you. What's -4 squared? 16. 5 and -4 is, right? So 16 minus 20 is -4 plus 6. 2. Is 2 bigger than 0? Okay, so we're good on that side. What's an easy number on the right-hand side to try? Let's try 0. If I plug in 0, what's 0 squared?
0.
Plus 5 times 0. Is 6 bigger than 0? Yes, so we're good to go. So our shading is correct. So negative infinity on the left over here, positive infinity on the right. What would our interval notation look like? Parenthesis, negative infinity to? Perfect. Union. Perfect. Good. Very good. Yes. All right, let's come on over here. Everything to one side first, please. Subtract x and 2, so I have x squared minus x minus 2 less than 0. Everything's on one side, so I have less than. Where do I color if I have and? In between. And what kind of dots do I have? Both of them are open because it's not included. Good. So now that we have a picture in our mind, let's factor. Factors of -2 that multiply to give me -2, but add to give me a -1. -2, +1. Good. So I have x values at +2 and -1. So -1, 0, and 2. What kind of dots did you say? Open. Good. What's an easy number in the middle to plug in? 0. So if I come up here and I say 0 squared less than 0 plus 2. Is 0 less than 2? Yes. You want to check something on the outside just to make sure? Go ahead. -2. -2 squared is 4. And then -2 plus 2 is 0. Is 4 less than 0? Nope. Okay, so try +3 on the right. 3 squared is 9. And then 3 plus 2 is 5. So is 9 less than 5? No. So we're good with where we colored. Hold on one sec. What is our interval notation? -1, comma 2. What's on both sides? Parentheses. Good. Question, Kara. All right. What? 2 more? All right. Look at this one. This one looks, oh my gosh. Big deal. What do we have to do with everything? It needs to be where? To the other side. So I'm going to subtract 3x squared. And I'm going to subtract 2, correct? So if I subtract 3x squared here, I have 2x squared, right? Plus 3x minus 2 greater than or equal to 0. That says greater, right? Which way do we color if it's greater?
Outsides.
Outsides. And what kind of dots do I have? They're closed dots because it's or equal to. All right, so we're going to factor. Guys, you're factoring where A is not 1. This is not new. A times C, 2 times -2 is -4. What are the factors of -4 that multiply to give you -4 but add to give you 3? +4 and -1. Now my A term is not 1, so what do I do with it? Divide both factors by 2. So this becomes x plus 2, and this becomes 2x minus 1 equals 0. Yeah? So I have two boundaries. I have 2 points I have to put on my number line. One's going to be at -2, and the other one's going to be at +1/2. How did I get that? I just solved each parenthesis, that equal to 0. So now, to your number line, I have -2 on my number line. I have 0, and I have 1/2. What did you tell me about the dots at -2 and 1/2? They're both closed. Because it's included. Those two values are included. And grade or, which way do I shade? Outside. To the left and to the right. So when you go to just test your points, let's try 0. 0 is the easiest thing to do. Should 0 work? No. So go back up here. Watch. When I have 5 times x squared plus 3 times x, if I plug in 0 for x, what's the value on the left-hand side? When I plug in 0 for x on the left-hand side, it's 0. Then I have 3x squared. Well, if I plug in 0 there, what's 3 times 0 squared? 0. So this just works out to be, is 0 greater than or equal to 2? No, it's not. So 0 should not be in your solution, and it's not. Go ahead and pick -3 on one side and 1 on the other side. I promise you it'll work. But just notice, when you test points, if you have it shaded, it should work. If you don't have it shaded, it should not work. So interval notation-wise, from left to right, what is my interval notation? Parenthesis, negative infinity to -2, bracket, union, bracket, 1/2 to, perfect, good job. All right, let's do the last one. Where is it? What do I need to do here? Move everything to one side. So I have x squared plus 2x minus 3 is what? Greater. I like the way you said that. It's greater. I know that's not how you spell greater, guys, but greater. What do we do with greater? Inside or outside? Outsides. And what kind of dots do I have? Open. There's no or equal to underneath. Good. So now we go through the same process that we've done 17 times today. I need to factor. What are the factors of -3? That'll multiply to give me -3, but add to give me 2. Yep. X plus 3 and x minus 1. So I have test boundary lines at x equals -3 and x equals 1. -3, 0, and 1. What kind of dots? Open and open. And it's greater. So which way should I go? Outsides. So Alec, in this situation, if I plug in 0, it should not work. You are correct. So go up to your original. What is 0 squared?
0.
Plus 2 times 0.
0.
Is 0 greater than 3? No. Pick a number on the left-hand side of the graph. So -4. What's -4 squared? 16. And then what's 2 times -4? Okay, so 16 minus 8 is 8. Is 8 bigger than 3?
Yep.
Okay, we're good. Check on the right-hand side. Try 2. What's 2 squared?
4.
Plus 2 times 2 is 4. So 8. Is 8 bigger than 3? Yep, so we're good. So interval notation-wise, guys, what's my answer? Excuse me. Negative infinity to -3, parenthesis, union, 1 to infinity. Awesome. Good job, guys. Little extra thinking, a little bit, but you guys did a really good job. So tomorrow, what we're going to do is I have some practice problems that I'm going to give you, and it's going to be due at the end of the period. You can work together. You can work with me. We're going to just work through these because we need to practice. We're then going to start section 1.8, which is the same similar concepts. We're doing inequalities and equations, but instead of square roots and stuff, we're going to do absolute value. So things are a little different with absolute value because absolute value always is what? Positive. So it kind of changes some things around a little bit, but we will do that on Friday.